My name is Ankit Raj and I am from Dr. B.C. Engineering College, Durgapur, West Bengal, India. So my topic is all about phase-wise stochastic scaling and dynamical analysis of pan-India COVID-19 outbreak. So let's hear from it, the introduction part. So as we know that the COVID-19 has is in occurred, the outbreak of COVID-19 occurred in different parts of world, and it is a major concern for all of the administrative units of respective countries. So India, with a popular population of more than 1.34 billion, has the second largest population in the world, has been facing difficulties in controlling the transmission of COVID-19 in world. So this in this scope of a study, I have presented as a stochastic parameters as well as few dynamical characteristics of the outbreak that will be classified to in for internal dynamics of the pandemic as well as phase-wise scaling with different window size has been done in this project. So let's see. The experimental data that has been used here is collected from the repository of COVID-19 data center for system science and engineering at John Hopkins University, that is publicly available at this the following site which I have given. So here is the phase-wise decomposition of data that I have collected from the site. So this here is the full span signal of the data that we have collected, which is further subdivided into three phases of the data. So the phase 1 and phase 2 corresponds to the phase 1 and corresponds to the first and second wave that has happened in India, and the third phase is correspond to the leftover of second wave and full third wave that have occurred in India. So we have used some scaling analysis for the estimation of Hurst exponent. We have used 4 different methods for calculating the value of H so that it has more convincing values. So let's go to the results and discussion. These are the mean, median, mode, standard deviation, skewness, and kurtosis of the data that I have collected from the site. Here we can see that there is a standard deviation that shows here is the highest that indicates that the data are more spread out and difficult to infer due to different peaks and waves, and in as compared to phase 1 and phase 2, the full span data is higher. So in compared to phase 3, it is much lower. That indicates that the data are clustered around the mean and may continue in a constant rate without any further massive outbreak. So let's go further. The skewness. Skewness is the measure of how much the probability distribution of a random variable deviates from the normal distribution. So in case of full span, the skew as well as the phase 1 and phase 2, the skewness are positive, and in case of phase 3, it has a negative skewness. Similarly, in case of kurtosis, phase 3 has a double indicating letter in after the phase 1 and phase 2. So let's hear for the average peak-to-peak duration of the data. It suggests that during second wave or phase 2, the outbreak was more consistent than the phase 3, as it has decreased in phase 3. Here the table 3, it has a fractal dimension that represents the roughness of the signal in terms of numbers. The value of fractal dimension here is independent from scale, and it is evident from the table that though the values of fractal dimensions are different, but they are in a close proximity range from 1.2427 to 1.7832. These results confirm that under observation of found statistical self-similarity instead of strictly self-similarity, and thus COVID-19 spread will be more considered to follow the properties of fractals. Now we have calculated the Hurst exponents with 4 different methods. The value of Hurst exponents signals implies that whether it has some underlying trends or it is just some pure random walk. So from the table 4, it is evident that first exponents of full span phase 1 and phase 2 is less than is greater than 0.5, which implies that the spread mechanism is persistent and of long memory process. On the contrary, in case of phase 3, it is less than 0.5. That suggests the process is anti-persistent and have short memory. This result leads to a constrained forecasting of third wave of COVID-19 in India. Conclusion, in this present scope, it has been concluded that the daily spread of COVID-19 in India is governed by non-stationary process with characteristic of fractal Brownian motion. From the starting of spread till the end of second wave, the pandemic was persistent with long memory, whereas but in phase 3, it is anti-persistent with short memory. Thank you.